Okay, we're going to talk about some of the rules for taking derivatives. Some shortcut rules. For example, if f of x is just a constant, well, what is that going to look like? Remember, another name for f of x is y. So y is always the same. For argument's sake, let's say c is there. So this here is the line y equals c. More parallel to the x-axis than I drew. Why is that true? With any point on this line, if you happen to go and look at the y-axis, what do you see but good old c? Right there is c. Right there is c. If you pick this point, you look to the y-axis, there's c. Y is always c. Okay, so now the question is, given any point, say the point right there, the slope of the, first of all, the slope of this line is 0. Because the slope is the change in y over the change in x. But the change in y is 0. Any 2 points, there is no change in y. After all, if there was a change in y, then the change in y would not be 0. It would be 3 or 7 or negative 2. Well, if you take any point, say this point right here, it turns out that the tangent line is that point. Tangent line is the tangent at this point is the line. If you were to take this point right here, the tangent line at that point would be this line, and the slope is 0. So what I'm saying is, if f of x is a constant, then the derivative, no matter what x is 0. Now, I think as a calculus student, you should be able to prove that. And basically, we're going to use the definition and we're going to prove it. So whenever you have a constant, the derivative is 0. That is, if f of x is any number, 2, or pi, or 99, or negative 3 over 4, then the derivative of f of x is 0. And the proof is straightforward. So we're going to do the proof where the derivative equals c. So by definition, f prime of x is the limit as delta x goes to 0 of f of x, f of x plus delta x, f of x plus delta x minus f of x all over delta x. So now f of x is a constant. F of x is equal to c, some number. So if I replace x with 7 in the brackets, then over here I have to replace x with 7. But there is no x. That is, f for 7 is that constant. If that constant is 13, then f for 7 is 13. F for 71 is 13. F of anything is 13 or c. So this equals the limit as delta x goes to 0. F of anything is c, minus f of anything is c. And this is where we're getting 0. C minus c is 0. But delta x, the bottom, is not 0. Remember, 0 over 0 is not 0. Delta x is getting close to 0. It's never 0. 0 divided by not 0 is 0. The derivative of a constant is 0. Let's go on to the next rule. The next rule is very powerful as well. It's called the constant multiple rule. If you have a constant times the function, how do you do that? So we have this theorem or fact. It says if, let's just say it differently, the derivative, if it exists, the derivative of k is a constant, times f of x is just keep the constant and then take the derivative of the function. You don't have to worry about the constant. Okay? If some function, okay, their derivative of 3 times some function, x cubed plus 2x minus 5. This is just 3 times, I guess this is notation now, times not that function, but the derivative of the function. That mark right there says take the derivative of that. Okay, now I think you should be able to prove this. Okay, so the derivative of this, the way to say derivative is prime. Well, this is equal to the limit as delta x goes to 0. I mean, we could say, call that whole thing h of x. So then we have h of x plus delta x minus h of x all over delta x. And this is equal to the limit as delta x goes to 0. Now, I just stated that h of x is k times f of x. Just like always, whatever I put in for x, you should put in for x. If I ask you what h of 7 is, you should say, oh, that's k times f of 7. If I ask you for f of, I meant to say h of x plus delta x, well then you should say k times f of x plus delta x minus h of x, which is just k times f of x. And all of this gets divided by delta x. Now, I'm able to pull out k in the numerator. I can pull out k. This equals the limit as delta x goes to 0 of k times f of x plus delta x minus f of x. That's the numerator. Because in this factor and this factor, I meant to say term, in each of those two terms, one of the factors is k. And as a result of that, I can factor out k. And of course, this all gets divided by delta x. But now when you have a product, limits are very friendly. You could take the product of the limits. That is, you can take the limit of the first factor and multiply it by the limit of the second factor. It's very, very good for you guys to learn the limit rules, especially since they're so friendly. Anything reasonable you can do. It's unreasonable to think if you have a product you can add. Alright, so the last line, I could make it the limit as delta x goes to 0 of k times the limit of the second factor, which was f of x plus delta x minus f of x all over delta x. Okay, so it's this limit times the second limit. Now, I'm assuming that the derivative exists. I should have stated that. This here, by definition, is f prime of x. Now, as delta x changes, I don't care if it goes to 0 or to 99. As our f of x changes, as delta x changes, the constant doesn't change. It's just k. That is, as delta x gets smaller and smaller and smaller, k stays k. And we get the result that we wanted. Okay, the next one, next rule you should know, we won't prove this, and you'll really like this rule. Okay, actually, the next one we should state is the following. If f of x and g of x are both differentiable, that is, the derivative exists, then if you have a sum, like f of x plus g of x, and you want the derivative of it, then you can take the derivative of f of x and the derivative of g of x and add them. If you were subtracting them, f of x minus g of x, then you can compute the derivative that way. Okay, that's another rule. The next rule, so this rule that we just stated, that's very powerful. Okay, and we'll talk about why in a moment. Right now, I admit it's very abstract. In fact, not only is it abstract, it's wrong. F of x plus g of x, the derivative, is f prime of x plus g prime of x. Sorry. Okay. This is a theorem or a fact. The next theorem is the following. If f of x is equal to x to some number, then the derivative of f of x is, well, you keep x the same. You play games with the power. You bring down the power, you make the new power one less. Okay, this one is gold. This one you need to know. So now, if somebody asks you, they say, if f of x is equal to 3x to the fifth plus 2x cubed minus 7x, we should be able to find the derivative. Okay, if that, then find f prime of x. We should be able to do this. And the way we should do this is, you might want to think of that as one function plus another function minus the third function. That theorem that I gave on the very top of the page, where I only said we're adding and subtracting two functions, this works for 22 functions. If you're adding or subtracting many functions, take the derivative one by one and add them. Now, how might we find the derivative of the first term? Well, here we have a function times a constant. The constant multiple rule says keep the constant and multiply by the derivative of the function. So now we use this rule right here that says keep x, bring down the constant, the power, and make the new power one less. But that gives us 15x to the fourth. In fact, you could have just multiplied the 3 by the 5 right away. So like I said, you get 15x to the fourth plus. Now we want to take the derivative of 2x cubed. The best way to do that is to bring down the 3, but it's going to get multiplied by the 2. And then make the new power one less, plus 6x squared. Now the next one is a bit messy. 7x is equal to 7 times x to the 1. So to take the derivative, you bring the power down, multiply by the constant in front. 7 times 1 is 7, and then you make the new power 1 less. But the derivative, no derivative. X to the 0 is 1. So you get 7 times 1, or 7. The derivative of a number times x is just a number. Think about what derivative means. It means slope. And if you have y is equal to mx plus b, in our case, b is 0. But the derivative, the slope, is always m. The derivative gives you the slope. In our case, the slope is 7. So let me erase a lot of this. Let me erase this. And then I'm going to say the answer is minus 7. The derivative of a constant times x is just a constant. Compare the derivative. I'll give you now the f of x. F of x is 7 times 2x cubed minus 4x plus 5. The derivative. Think of this as a constant times our function. That is, the constant stays and it gets multiplied by the derivative of the function. The derivative of this minus the derivative of that plus the derivative of 5. The derivative of 2x cubed, I'll multiply the 3 by the 2, and that power 3, make it 1 less, minus. The derivative of a constant times x is just a constant. And the derivative of a constant is 0. There's no need to even denote that you're adding 0. There's your answer, and it's even factored. That is, we factored out the 7. You could have distributed the 7 before we took the derivative. You would get 14x cubed minus 28x plus 35. But the problem is now you're going to have to know what 3 times 14 was. And if the power of x was other than 1, maybe it was 7. Now you have to know what 7 times 28 is. Okay, it's best not to multiply out. Besides, even if you did, after you take the derivative of this, you should factor out the 7. Okay, let's look at some more. Yeah. So remember, we only know how to, other than constants, we only know how to take the derivative of x to a number. If it isn't x to a number, we don't, or a constant times x to a number. If it isn't a constant times x to a number, we don't know how to take the derivative. So I'll give you that f of x is equal to 3 over x squared minus the cube root of x plus 3x squared, or just x squared over 5. X squared over 5. And we'll talk about each one separately. Each one meaning terms. You want to take the derivative of each of them. First minus the second plus the third. Now, 3 over x squared, that's not a constant times x to a number. It's the constant divided by x to a number. So what we're going to do is, we're going to bring this to the top. And when you cross the division line, all you do is change the sign of the power. Instead of 2, it's negative 2. Now I can take the derivative. Notice that I haven't been writing equal. Let me take the derivative first. We multiply, we get negative 6, and we make the new power 1 less. So it becomes negative 3. Now this is not equal. This is f of x. Well, let's actually name it that. This here is f of x, but this here is f prime of x. But they're not equal, so don't write equal. Now final answers should not have negative exponents. You have a negative. The exponent of the 6 is understood to be 1. That's a positive number, so it can stay. The exponent of the x is clearly negative 2. Since it's in the numerator, I'll put it in the denominator, and I'll change the sign. So the derivative of the first term is negative 6 over x squared. It's negative 6 over remember is that you have the nth root of x to, say, the a power. This is x to the, this number over that number, a over b. And if any one of these numbers is not there, say you just have this, square root of x. Well, what you need to realize is two things. This is shorthand notation for the following. If there's no exponent, it's understood to be 1. And if there's no number in front here, it's understood to be 2. So, we get x to the 1 over 2. So, cube root of x, well, we have one of the two numbers we need. And if the number under the radical isn't there, it's understood to be 1, and it's a power. So it's x to the 1 over 3. Now, to take the derivative, it's a routine. X to a number, bring down a number, and make the new number 1 less. Now, let's look at how we can do that nice and cleanly. If you have a fraction and you want to take away 1, you should think of the 1 as b over b. Now we have two fractions and they have the same denominator. So we keep the common denominator and we do what the top says. A minus b. A minus b. If you have a over b and you want to take away 1. Well, how can we look at the beginning? More importantly, just look at the initial fraction and figure out what we get when we take away 1. Well, the answer, the denominator has the same answer, and the numerator, here it is the top number minus the bottom number. Okay, if somebody asks you what 12 over 5 minus 1 is, the bottom is 5, and now you should do top minus bottom. 12 minus 5 is 7. Very powerful. If you have 2 over 5, and somebody asks you to take away 1, well, the bottom stays the same, and then you do 2 minus 5, which is negative 3. Now you should take away 1. Don't struggle with that. Just take away. The numerator must be the top minus the bottom. Boom, minus bottom. Okay, but you have to know how to subtract. Okay. So now we're ready to do that right here. We want to find out what the exponent should be. So I do 1 minus 3. That's negative 2. That goes on top over 3. Now final answer should not have negative exponents. The exponent of 1 is 1. The exponent of 3 is 1. The exponent of x to the negative 2 is negative, and it's in the numerator. So I put it in the denominator. And I make it positive. So it's negative 6 over x squared minus 1 over 3 x to the 2/3 power. Okay, now we need to look at the next one. Okay, let me erase all this, and we look at the next one. So like I said, let me erase this, please, and we'll look at the next one. The next term. The next term, you have to be clever. You have to realize that that's a constant multiple rule. That's nothing more than a constant multiple rule. Multiplication and division are basically the same. That is, x squared over 5 is nothing more than 1/5 times x squared. I know that's true, 1 times x squared is x squared. And if you like a 1 on the bottom, 5 times 1 is 5, or 5 is just 5. And that's what the bottom is. Okay, because the 1/5 is a constant. So what we're going to have is 1/5 times the derivative of x squared, which is 2x. And you get 2x over 5. The easier way of doing it is there's a constant on the bottom, just keep it. The derivative of 2x, the derivative of x squared is 2x. So we get plus 2x over 5. And that's the derivative of that function. Okay, so basically what you need to do is rewrite the function so that each term is nothing more than a constant times x to a power. So let's try a couple of others. Suppose you have this one. Suppose you have y is equal to 1 over 3x squared minus the 5th root of x squared minus 4 over the 7th root of x cubed. So the main thing in these problems is to rewrite it. Now, and you can take as many steps as you want. If you have a product and it's being squared, each of those two factors get squared. That is, you get 3 squared times x squared. 3 squared is 9, x squared, Okay, minus, this is x to the 2 over 5. Minus 4 over x to the 3 over 7. Okay, now we're in a position to write it where all the x's are in the numerator. I can take this x, boom, put it on top. The 9 stays on the bottom, but the x squared goes up to x to the negative 2 times the 1. It's still x to the negative 2. Minus x to the 2/5 minus 4. Bring this mess to the top to change the sign of the power. Okay, now I'm in a position to take the derivative. It's negative 2x, 1 less, negative 3, over 9. The 9's a constant. It just pretty much hangs out there. Minus x, bring down the power, make the new power 1 less. So I'll do 2 minus 5, that's the numerator, over that same denominator. Minus, bring down, well maybe it's minus, negative 3 over 7 times negative 4. A negative times a negative is positive. 3 times 4 over 7. 4 times 3 over 7, 12 over 7. And now you make the new power 1 less. The denominator doesn't change. Negative 3 minus 7 is negative 10. And this here is y prime, excuse me. So the calculus is done. The calculus wasn't very hard. It was just bringing down the power and making a new power 1 less. Knowing the algebra is the whole thing here. Okay, now, like, I don't know if I said it yet, but you're not done until you have no negative exponents. So we go term by term and we look. If there's a negative exponent, we have to do something. And there is. But it's not on the 2, the negative exponent, and it's not on the 9. It's on the x. And the x is clearly in the numerator. So you put it in the denominator, change the sign. Minus. The 2 doesn't have a negative exponent. It's in top, it stays there. The 5 doesn't have a negative exponent, so it stays in the bottom where it is. But the x, which is in the numerator, has a negative exponent. So I moved the base, I moved the x to the denominator, and I changed the sign of the power. Make it plus 3/5. Plus the 12 over the 7, but this is in the numerator and has a negative exponent. So I put it in the denominator and I change the sign. I make it just 10 over 7. And there is your derivative. Okay, so now, what if they give you a problem like this? What if they give you this problem? Let me erase my board first, please. What if they tell you that f of x, so let's change it to g of x. G of x is equal to x minus 4 squared. Well, that's not in the form of, that's not a sum of x to powers, or constant times x to power. All we know how to do is take derivatives of x to powers. So what I'm going to do is I'm going to square it. And I'll get the x squared, I'll get minus, puts this a minus in the middle. This times this is 4x, times 2 always is 8x, plus the 4 squared. Okay? Take the derivative of this, and it's straightforward. The derivative of x squared is 2, bring down to 2, bring down to 2, make the new power 1 less. But x to the 1 is just x. Minus the derivative of a constant times x is just the constant. Plus the derivative of constant is just 0. So 2x minus 8 plus 0 is just 2x minus 8, and there's the answer. There's the answer. If I told you that h of x was x times 3x minus 5x cubed, you don't know how to take the derivative of that. Nobody ever said that if you have one function like x and you're multiplying it by another function like 3x minus 5x cubed and you want the derivative, nobody ever said that that's the derivative of f of x times the derivative of g of x. We never said that, so let's not put an equal sign. Okay, so again, we only know how to take the derivative of a constant times x to a number. And this priming derivative. Multiply the n by the k, make the new power 1 less. N minus 1 is 1 less than n. So, to get it to look like a sum and differences of things like this, it being h of x, I'll distribute the x. So now I have 3x squared minus 5x to the 4th. But that's exactly what I want. A constant times x to a power plus or minus, in this case minus, a constant times x to a power. But now it's a piece of cake. Taking derivatives once it's in proper form is very, very simple. Very simple. And if you're having problems with it, it's just the algebra you're having a problem with, and you need to review it somewhere. So we have that h prime of x is equal to the derivative of this, which is 6x, multiply their 3 by the power, get 6, and the new power becomes 1, and you don't have to write 1, minus 4 times 5 is 20, make the new power 1 less. There's the derivative. Okay, so now we'll do something a little bit different. I'll give you a function, and I'll ask you to find the equation of the tangent line at a given point. Okay, given, you're given that f of x is equal to x cubed plus 2x plus 1. I want you to find the equation of the tangent line at the point 1, 4. Now what is this saying? You have some graph. Let's make believe it looks like that. And right here is 1, 4. Now, I picked x as 1, but then I plugged it in to f of x to make sure that's 4. After all, 1 cubed is 1, 2 times 1 is 2, plus 2, plus 1, well that's 4. That's how I got 4. Now, what this problem is asking is to find the equation of the tangent line. To find the equation of that line. Well, we have a point. Now all we need to know is the slope. But the slope is the derivative at 1. And you have to start making that connection. The slope is the derivative at 1. So let's find the derivative. Let's find f prime of x. And it's 3x squared plus 2. The derivative of a constant times x is just a constant. Plus the derivative of 1 is 0. So there's f prime of x. If you plug in 1, you'll find the slope that we want. It's 3 times 1 squared, which is 1. 3 times 1 is 3, plus 2 is 5. So now we have the slope. We have a point, and we have the slope. So let's find the equation. That's all you need to find the equation of the point and the slope. We know every line can be written as y is equal to m, which is 5. Y equals mx plus b. We just have to find b. We used the fact that m was 5. Now we're going to use the fact that 1, 4 is on the line. Y is 4 and x is 1. So 4 is equal to 5 plus b. Bring the 5 to the other side. 4 minus 5 is plus b. Negative 1 is plus b. This symbol, equal, has many, many meanings. One meaning is, wherever you see negative b, write negative 1. Noah, what do you know? I see negative b right there. So y is equal to 5x. Instead of negative b, I can write negative 1. Y equals 5x minus 1 is the equation of that line. Okay, that completes this section. Good luck on it, folks.